Hey guys, you all did a brilliant job the other day at discovering the binomial theorem. So today we're going to just have a look at what it looks like when we put it into practice. Okay, we found out that there are lots of patterns when we expand things like this. 2x minus 1, anything to the power of 3 and above is just really tedious, and we want to use these patterns to help us do these expansions. So let's say we wanted to do 2x minus 1 to the power 5. So the first thing I ask myself is, how many terms are we going to have? Well, since we know that the a term here goes from 5 down to 0, and the b term goes from 0 up to 5, that gives 6 terms. From 0 to 5 is 6 terms. So we know there's 6 terms in this particular situation. So this is what I'm going to do. I'm going to write them down. I'm going to put places, and we're going to fill in these terms as we go. So we've got first term plus second term plus third plus fourth plus fifth and plus the last term there. Okay, and we've got 3 parts. We've got the a term, we've got the b term, and we've got the coefficients. Okay, well, let's go and deal with the coefficients first. Remember, we use our NCR, our combinations, to work out these. So our first one, we know it's going to be a 1, but we could write that as 5 choose 0, couldn't we? And then we have 5 choose 1, 5 choose 2, 5 choose 3, 5 choose 4, and 5 choose 5. Okay, now of course there's another way of writing that. Just a reminder, you may see this. NCR can also be written like this, NR in parentheses. So you've got a couple of ways. Just be aware, sometimes it's easier to write like this, and I might do this next time in the next example. All right, now let's look at our a term here. All right, the patterns we found was that the first term goes from the power 5, from the power n, all the way down to 0. So let's put those in. So we've got 2x to the power 5, 2x to the power 4, 2x to the power 3, 2x to the power 2, 2x to the power 1, and of course you know that's 2x to the 0, but as you know there's no a term in that last one, it's just going to be the b term. But I'm just going to put it down in this situation so we get used to seeing it. Right, and let's go and do our b term here. Here's our b term. This started at a power 0 going all the way up to n, all the way up to 5. So we've got negative 1 to the power 0, and as we know before, we don't have any b term in the first term, it's just the a term. But we'll put it in just to demonstrate this time. Then we've got negative 1 to the power 1, negative 1 to the power 2, negative 1 to the power 3, negative 1 to the power 5. Now you may see straight away that having a negative b term is going to perhaps do something to the terms, whether it's positive or negative. Alright, so now it's time to start figuring it out. Well, let's go back and deal with these terms here. 5 choose 0. Now we know that's 1, so I'm going to put my 1 down there. I'm just going to go and show you a reminder once again about how to do those. So 5 NCR, so let's look at let's grab our calculator here. Alright, so if I want to do 5C1, I enter my 5. Oh, better turn it on. Enter my 5. I go to my math and my probability menu, and I select NCR. 5 choose 1, and we get 5. So I can put that in over here. Let me shrink this back up again. I'll put him up there. So this time I've got plus 5 plus, and if we do the same to all of those, we end up with our coefficient of 10, 10, 5, and of course we know the last one has a coefficient of 1. Alright, let's go and do our a terms, our 2x terms. 2x to the power 5, remember to put those parentheses, you're raising the whole 2x to the power 5. If you write 2x to the 5, Mathematically, that's wrong because you're only raising the x to the 5. So just be a bit careful. Put that whole term in parentheses. So we've got 2 to the power 5. So we've got 32x to the power 5. 2x to the 4. 2 to the power 4, 16. 16x to the 4. 8x cubed. Basic math here. 4x squared. 2x. And of course, 2x to 0 is 1, isn't it? It disappears. So I'm not going to put that there because I know it's not going to be there. All right, now let's go and have a look at our b term. Negative 1 to the 0, 1. Remember, it disappears. Negative 1 to the power 1. Well, that's actually going to have the effect of, well, it's going to be negative 1, isn't it? Okay. Negative 1 to the power 2 is just positive 1. Negative 1 to the power 3, negative 1, negative 1 to the power 4, positive 1, and negative 1 to the power 5, negative 1. We'll have a look at that. We've got all our stuff noted out. It's just a matter of simplifying now. So let's have a look at what this is going to look like simplified. Let's neaten up this first term. So we've got 32x to the 5 is our first term. Our second term, 5 times 16, I think we get 80 there. But look, we have a negative 1 here, so what effect's that going to have over here? It's going to make that negative, isn't it? So let's just make that negative now. So we're going to get negative 80x to the power 4. That's a positive, so this term's going to stay positive. So we've got plus 80x cubed. Oh, we've got this again, negative. That's going to change that negative there. So we've got minus 40x squared. That's a positive, so we'll have plus 5 times 2x, 10x. And we've got that negative affecting the sign there. So we've got minus 1. And there we go. There's our 1, 2, 3, 4, 5. 6 terms of our binomial expansion 2x minus 1 to the 5.